It is often said that the first half of the 20th century was the age of physics. The curvature of space-time, the dynamics of subatomic particles, the Big Bang and black holes, the unleashing of atomic energy that could power whole cities or obliterate them. All these discoveries burst forth to revolutionize science and change our everyday lives. One could say it was the Big Bang of physics itself, taking place roughly between 1905, when Einstein gave us E equals mc squared, and 1947, when the transistor was invented at Bell Labs. As the second half of the 20th century dawned, biology began to nudge physics out of the scientific spotlight. And by biology, I mean DNA. After all, that half-century more or less began with Francis Crick and James Watson's momentous discovery of the DNA double helix in 1953, and it ended with the Human Genome Project from 1990 to 2003, which decoded all of our DNA into a biological blueprint of humankind. Today, everyone knows DNA's greatest hits, that it contains our genetic information, that it can be used to trace our ancestry and pinpoint hereditary diseases and solve crimes. DNA has even entered the vernacular. If I tell you that something is in my DNA, whether it's a devotion to hiking in the mountains or a love of Thai food, I'm saying that it's a core part of who I am, my essence. During the age of DNA, RNA was mostly overlooked by the general public. Certainly textbooks described and students learned how RNA, the ribonucleic acid to DNA's deoxyribonucleic acid, was copied from the double helix, and how messenger RNA, or mRNA, worked to transmit DNA's code to instruct the synthesis of proteins. But RNA was never the star of the show. It was like a biochemical backup singer slaving away in the shadow of the diva. Yet, to those in the scientific community, RNA's previously unappreciated talents began to become apparent. RNA is tiny, measuring only about a nanometer in diameter. If you stacked molecules of messenger RNA side by side, you could fit 50,000 of them within the breadth of a single human hair. Yet, as researchers started to discover what RNA lacks in size, it makes up for in versatility. Folding into origami-like shapes, it can pull off wild stunts that make its genetic parent DNA look like a one-trick pony.